Welcome to the new video. This video is very important because in this we are dealing with full circles concept. As you can see, the topics and the different points which are indicated in this page. Let us see what are the points we will going to discuss in this video. First one, circle passing through given non-collinear points. Second topic we will going to deal here, secant and tangent of the circles. Third point we will going to deal with touching circles. Fourth point we will going to talk about arcs. Then we will going to talk about all the angles in this chapter, that is circle chapter. And then the last one we will going to deal with cyclic quadrilateral. So all these topics will be covered in this video. So first we will going to learn the circle passing through given non-collinear points. First one, when one point is given to us, we can draw as many circles we want. As you can see, point T is given and I had shown you only 3 circles, but you can draw infinite number of the circles passing through that point. When the 2 points are given, again we can draw infinite number of the circles, because the 2 points can have a perpendicular bisector and any point on perpendicular bisectors are equidistant from the end point of the segment. Therefore, we can draw infinite number of the circles when the 2 coplanar points are given to you. Any point on the perpendicular bisector of a segment are equidistant from the end points of the segment. Third one, when 3 non-collinear points are given. Here if the points are collinear, no circle can be drawn. But 3 non-collinear points are given, then a unique circle can be drawn. Unique means one circle can be drawn, which is also known as circumcircle. Clear? And it's so on. If the 4 points are given, one only unique circle can be drawn. Clear? Which is also known as circumcircle. So here we have no circle passes through 3 collinear points. Clear? So I hope this concept is clear. The number of circle passes through 1 point, 2 point, 3 or more than 3. And what will happen when the points are collinear? Then no circles will pass through it. Let us go for the next topic. Secant and tangent of the circles. So first part, line AB intersects circle at point A and B, so it is called secant. See here. So line AB is a secant. Clear? Segment AB is also called as chord. Now a line intersecting the circle at point T, so it is called as tangent, because the line having one point common with the circle. See here. Clear? Next part, line PQ is a tangent, as you can see. Here when the tangents are given, we have different points here. Touching circles. See, the coplanar circles having one and only one point in common is called as touching circle. So the common point is called as point of contact, and the center of the 2 circles and the point of contact are collinear. So here the circles are touching circles and we have point of contact, that is T here. The theorem of touching circle, if the 2 circles touch each other, their point of contact lies on the line of joining their centers. Next one, a tangent at any point of a circle is perpendicular to the radius through the point of contact. See. Converse, the line perpendicular to the radius at its outer end is tangent to the circle. And last one, the tangent segment drawn from the external point to the circles are congruent. We have tangent segment theorem, as you can see here. R is the point given outside, so PR and QR are the tangents given. So you can see all these are the tangents in the figure. First case there, point T is common. Second case means when the two circles are touching, again we get common tangent, what we call them. Here the two circles are internally touching, we have common tangent. So you can see that when the tangent is perpendicular on radius, one property. The tangent and the line is perpendicular on the radius, then we call them as a tangent. An exterior point. One more diagram is there. Common tangent one again. When the two circles are touching, you will have one common tangent, as you can see, passing through the two intersecting point. It can also have the other two blue lines as a common tangent. So this is all in giving to you about the tangents. I hope it is clear. Let's go for the next topic. Now we are talking about arcs. As you know, we have congruent arcs. So for two arcs are congruent if their measure of central angle and radii are equal. The angles are equal and their radius are also equal, then you can have congruent arcs. For example, as you see in the diagram, two angles, central angles are measured 70 degree. So their corresponding arcs also will be congruent arcs. Property of sum of the measure of arcs. As you see here, if you have here 4 arcs, you can add up, it will give to you 360 for full circle. But if you take two adjacent arc AD and arc DC, AD and DC, you will see that one end point is common between the two arcs. So they are also known as adjacent arcs, and the adjacent arcs can added. So therefore arc AD plus arc DC will give you major arc ADC. The two adjacent arc can be added. Next one, the chord corresponding to congruent arcs of a circle are congruent. Means chord AB is equals to chord DC. Therefore, arc APB will be equals to arc CQD, or vice versa. Arc APB is equals to arc CQD, then chord AB will be congruent to chord DC. Clear? The next part here, the corresponding arcs of congruent chords of a circle are congruent. So arc chord AB congruent to chord CD, then we will get arc APB congruent to arc CQD. This is all about the arcs. Clear? Now let us go for angles of a circle. So first one is central angle. Angle AOB is central angle and the measure is equals to the intercepted arc. Therefore, major angle AOB equals to major arc ACP. Second one, inscribed angle. Angle ADB equals to half of major arc ACB. So we say that measure of an inscribed angle is equals to half of the measure of its intercepted arc. Third one, angle formed outside the circle but not on the center. See here, when the angle is formed outside the circle, then we will have two arcs in it. So therefore major angle BAC equals to half the major arc DXE minus BYC. That is difference. You can say that BYC minus DXE also. The intercepted arcs are arc DXE and BYC, and we find out difference between them. So here we have angle formed inside the circle but not on center. Here again we have two arcs, so we will going to get angle BAC equals to half the major arc DXE plus major arc BYC. So when the angle is formed inside, we add them. When the angle is formed outside the circle, we subtract them. Then we have theorem of angle between the tangent and secant. Tangent is CA and secant is CE. So the angle will be angle ACE equals to half major arc CXE, which is known as next part as tangent secant theorem. And now we have alternate segment angle theorem. Here we will have one inscribed angle and tangent secant. So the formula will become angle ACE equals to measure of angle CBE. Clear? Now we have certain property based on inscribed angle. So let's see that also. Angle inscribed in same arcs are congruent. See here, angle ACB equals to angle ADB because they are inscribed in same arcs. Angle inscribed in semicircle is a right angle. So here AB is the diameter, so you can say that arc ACB is 180, therefore angle ACB is 90 degree. Cyclic quadrilateral. All the vertices of the quadrilateral lies on the same circle, then the quadrilateral is said to be a cyclic quadrilateral. First one property, the theorem of cyclic quadrilateral, that is opposite angle of a cyclic quadrilateral is supplementary. Angle A plus angle C equals to 180, angle B plus angle D equals to 180. Now what is corollary of the cyclic quadrilateral theorem? An exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. See here, angle DCB, angle DCE equals to angle DAB. Let us see the other part. Converse of cyclic quadrilateral means how will you prove the quadrilateral to be cyclic or not? So if a pair of opposite angles of a quadrilateral is supplementary, then it is called as a cyclic quadrilateral. For example, rectangle square. Then if the 4 points are given to you and the angle formed on the 2 point by taking the other 2 point on one side, so line BC as you see in the diagram, out of the 4 point we have taken 2 such point where we can draw a line and the other 2 points lie on the same side of the line. If the angles subtended by point A and D are congruent, then we can say that points are cone cyclic, and the same property we can use to prove 4 points are cyclic quadrilateral. Clear? Thank you for watching it. Hope you have understood, and see you with the next video. But do not forget to share it and like it.